Which are the following pairs? Both species are not isostructural. Number of sigma and pi bonds are in pent 2 in 4i. Okay, this is conducted on 26th August of your. Please take 26th August paper. Forget about the year of previous paper. 26th August paper conducted here. Did you find? What is the first question? Number of sigma and pi bonds in bent 2 in 4i. Correct? So that is a direct question. You can write the structure and calculate. Including you have to count the bonds between C and H also. 10 sigma bonds and 3 pi bonds. The structure of intermediate A in the following reaction. So write this. When benzene is treated with N-propyl chloride, or when it is treated with isopropyl chloride, or when it is treated with propene in the presence of H plus, these two in the presence of AlCl, anhydrous. So actually all these will give same intermediate. So what is the intermediate in the first one? Cl minus is taken by AlCl3 to give AlCl4 minus. You will get a N-propyl carbocation, which is a primary carbocation. Primary carbocation undergoes rearrangement to give a more stable carbocation. So what rearrangement it will undergo? Anyone? Pick. We already discussed. Very good. 1, 2 hydride shift. So this H will migrate here. So you will get CH3, CH plus, CH, which is secondary carbocation. Here you will get directly. Again here you will get secondary carbocation. Here also you will get the H plus will add here. CH plus. So when benzene is treated with either N-propyl chloride or isopropyl chloride, isopropyl chloride or this one, any of these will use same intermediate. What is the name of intermediate? isopropyl carbocation, which is secondary carbocation. So that will attack benzene ring. So we get aromatic, electrophilic, aromatic substitution, EAS. Any positive species is called electrophile. So you get isopropyl benzene. This isopropyl benzene is also called cumene. What is the name of isopropyl benzene? Cumene. Cumene on aerial oxidation, O2 in air, forms an intermediate. You are asking that intermediate. But we have given some extra information also. How do you prepare cumene? So this intermediate is cumene hydroperoxide. It is called cumene hydroperoxide. So benzene to cumene. Cumene is nothing but isopropyl benzene. The reaction is called EAS, electrophilic. This is electrophile. Electrophilic aromatic substitution. So you get cumene hydroperoxide. So that finally, this cumene hydroperoxide so again I am writing the product or intermediate. If it is heated in the presence of H plus, a rearrangement occurs, resulting phenol plus acetone. So this is entire sequence, but they asked only about the intermediate. Now we are going for the next question. The correct structure of tribromo octaoxide. So 3 bromines, all bromines are connected with double bonded oxygens. So bromine can show a maximum valency of 7. Bromine can show because halogens have NH2, NP5. So total how many electrons? 7 electrons. Here what is the bromine valency? 6 with oxygens, 1 with bromine. Total 7. Whereas the middle one has only 6 valence. Both the terminal bromines have 7 valence. Next question. This is a regular order 4D, 5D, 5N. So you write N plus L values. If L is equal to 0, it is yes. P, L is equal to 2, L is equal to 3, F subject. Now if you write 5f, 5 plus 3, 8, 10 plus 11. Next is 6p, 6 plus 1, 7. Next 5p, 5 plus 1, 6. Next 4d, 4 plus 2, 6. Now these two have same n plus l, but n value of 4d is less, that's why it is having the lowest energy. This is above principle. Next question. Question number 50. Which of the following reactions are disproportionation reactions? That also student can easily identify. First one, cuprous ion in aqueous medium disproportionates into cupric and copper, plus 1, 2, plus 2 and 0. So in the reaction you have to write plus 1 on the left side, plus 2 it is already there in the copper, 0 on copper neutral atom. And second one also disproportionation, because manganate ion, MnO4 2 minus, right, it's named manganate ion. In acidic medium it converts into permanganate. So manganate ion plus 6, left side manganese plus 6, right side manganese plus 7 and plus 4. So only two disproportionation reactions. Now 51. Under isothermal condition, the gas at 300 Kelvin expands from 0.1 liter to 0.25 liter against a constant external pressure 2 bar. The work done by the gas. So work done by gas W is equal to minus P external into delta V. This is given as 2 bar into delta V 0.25 liter minus 0.1 liter. That is equal to minus 2 bar into this gives 0.1. 0.3 liter bar. Point 30 liter bar. But 1 liter bar is equal to 100 joules. They have given already. 1 liter bar is equal to 100 joules. 0.3 liter bar. So how many? You multiply that, you will get 30 joules. So in thermodynamics, we have done a problem on work done in isothermal process, which is minus P external into delta V. Now the next question. Actually out of syllabus, round up and mention environmental chemistry. Environmental chemistry. But as a general biology student, you know that nitrous oxide N2O, methane, CH4 and ozone. These three are greenhouse gases. They absorb high energy sunlight and reflect low energy light, so that they trap more solar energy in the stratosphere, in the troposphere in our region. More and more solar energy is trapped, the globe becomes warmer and warmer. This is they are called global warming. They are called greenhouse gases. The reason for greenhouse, if you go to any botanical laboratory or garden, there is a greenhouse built with glass. So the glass has a unique nature. It allows more energetic sun rays enter into the glass house. It is a transparent glass only, but won't allow high energetic sunlight. It will only allow reflect low energy sunlight, absorb more energy sunlight, release less energetic light. So the entire heat is trapped in the glass house. So you open the door and enter into the glass house. We used to go to Jodhpur University botany department. We have big glass house. As a matter of interest, we used to go there. So when you just open the glass house and enter, you will feel very warm. Some plants require that warm condition for their growth. So such plants are there in the glass house. It is greenhouse actually. That's why they are called greenhouse gases, which trap solar energy. But SO2 is liberated from volcanic eruption and also by burning of fossil fuels, like coal burning, use SO2. It is not a direct greenhouse gas, it is an indirect greenhouse gas. So that is the answer, SO2, which causes acid rain. Next question. For the cell reaction, 2Fe3 plus aqueous plus 2I minus aqueous, 2Fe2 plus aqueous plus I2. E0 is given. So delta G is equal to minus NF E0. This is the form. Here the n value is 2 because 2Fe3 plus, by taking 2 electrons undergo into 2Fe2 plus, it is reduction. 2I minus gives I2 plus 2 electrons. If you add the two equations, electrons will cancel. So whatever the net equation they have given, that you will get. So here n value is equal to 2 electrons. So now you substitute the values. So minus 2 into 96,500 coulombs into E0 is given. How much? E0 is given as 0.24 volts. This you will multiply, you will get minus, I have multiplied already, 46,320. Joule mole inverse. This by converting into kilojoules, minus 46.32 kilojoule mole inverse. Delta G naught, standard free energy change, is equal to minus NF E naught. This is called electrical work. It is a measure of electrical work. Coming to the next question, it is chemistry in enzymes basic question. It is also out of syllabus. But you mentioned, as a biology student, you know cofactor, coenzyme. Cofactor is an inorganic ion that will facilitate to act the enzyme in a proper way. Usually magnesium and Zn2 plus, Mg2 plus are cofactors for many enzymatic reactions. In case of organic cofactors, we call coenzymes, like NADH. NADH is a coenzyme. The most suitable reagent for the following conversion: 2-butyl giving cis-2-butene. Palladium is a catalyst actually. On the catalyst surface, H2 gas is adsorbed. This adsorbed H will add here and here in the same direction. That is called syn addition. That gives cis alkene. So hydrogenation using Lindlar's catalyst is a syn addition. Syn means adding the two components across the triple bond from the same side. If they come from opposite sides, you get a trans alkene. You got cis-2-butene here. What is this? Cis-2-butene. In your NCERT book, if you see the same point is actually copied from NCERT and given the question. If you treat with sodium in liquid ammonia, you will get a trans alkene. Sodium in liquid ammonia. So same thing, but you will get a trans 2-butene. Trans 2-butene. So this is very, very important. Lindlar's catalyst, H2, palladium, barium sulfate or carbon. Write one more point. If you don't use barium sulfate or carbon, if you don't use BaSO4 or carbon, complete hydrogenation occurs, resulting in alkane. Within brackets butane. Okay, and I'm going to add one more point. Barium sulfate acts as a catalytic poison. Barium sulfate acts as a catalytic poison. And close the active centers. Of the catalyst. resulting partial reduction to alkene. Any inquisitive student or student has some knowledge. Suppose if I ask you, what is Rosenmund's reduction?
Integrated number reduction in presence of billion something.
So it says whatever.
Oh, sorry.
She started, but correct, she what first, reactant later. Okay, no problem.
Is it correct?
Correct. So same Windlar's catalyst at that point also, because that is also in our syllabus. Acid chlorides of reduction or partial hydrogenation give aldehydes. Acid chlorides on partial reduction or partial hydrogenation give aldehydes. So here 2H are involved. This is called Rosenmund's reduction. If R is CH3, we got acetyl chloride. Acetyl chloride. What IUPAC name? Ethanoyl chloride. IUPAC we call as ethanoyl chloride. You get acetaldehyde. Acetaldehyde or ethanol. If you take benzoyl chloride, benzoyl chloride, you will get benzaldehyde. So discussing a question also cover here and there some points that we can totally churn the entire syllabus. So this is also a good idea of discussing each question. Next question. Which is the correct thermal stability order for H2E, where E is equal to some central atoms? So in P block, the thermal stability of hydrides decrease down the group. Decrease down the group. Due to decrease in bond energy. In P block, the thermal stability of hydrides decrease from top to bottom due to decrease in bond energy. So if we take 14th group, it is CH4, SiH4, germanium hydride, tin hydride, lead hydride. This is 14th group. In 15th group, ammonia, phosphine, arsine, stibine greater than bismuth ion. In 16th group, water, H2S, H2SE, H2DE, H2PU. In 17th group, so in the entire P block, same pattern follows. HF, HCl, HBr, so common point. Why does stability decrease? Due to decrease in bond energy between the central atom and hydrogen. For example, now they have given this one. 16th group they have given. In 16th group, the first hydride water, O is a small atom, form a strong bond with H. Strong bond. Because both the bonded atoms are smaller in size, smaller the size, more effective overlapping of orbitals, strength of the bond is more. Suppose if we go to H2PO, PO is a very big atom. And hydrogen is a very small atom. So the bond length is also too high. So bond length and bond energy are inversely proportional. Because this bond is too big, it can be easily broken. Bond energy is less. Here bond energy is more. So that is the reason for all the groups. So in 13th group actually, boron hydrates are very unstable. That's why they are called borenes. We discussed about diborane and all. That's the 13th group I did not mention. Next question. Which of the following is incorrect state? PbF4 is covalent in nature. That itself is incorrect because Pb plus 4 state, high polarizing power, but F minus, lowest polarizability. As per Fajan's rules, to have covalent character, both polarizing power of the cation, polarizability of anion, both should be high. Here one is high, one is the lowest. Moreover, lead is a metal, F is a non-metal. Metal-non-metal bond is predominantly ionic. So PbF4 is ionic. But PbI4 will have more covalent character. Because there also, PbI4 if you take, Here this has high polarizing power in +4 state. I minus is very big anion, highest polarizability. Since both are high, this is predominantly covalent. So covalent character for an ionic compound is actually, these are predominantly ionic compounds. Metal, non-metal means they should be ionic. But some ionic compounds will get covalent character. When they fulfill these two things, the cation should have high polarizing power, the anion should have high polarizability. What is polarizing power? It is the tendency to pull the electron cloud of the anion. What is polarizability? The anion should have a tendency to donate the electron cloud. If the cation has greater pulling nature, if the anion will have greater donating nature, then the electron cloud will concentrate between the two atoms. Whenever there is an electron cloud distribution between two atoms, that is nothing but like an orbital overlap, which is also an electron cloud. It will have covalent character. To have covalent character, there must be some electron cloud between the two atoms. When that electron cloud can develop, if the cation strongly pulls, if the anion has strong desire to donate the electron cloud, then only it is possible. Let's say in case of silver halides, this is the decreasing order of ionic character. AgF greater than AgCl greater than AgBr. So ionic nature decreases in this order. Suppose if they ask covalent nature, this is the decreasing order of covalent nature. This is covalent nature. Decreasing order. Now the second option, if you see the same question, SiCl4 is easily hydrolyzed. It's very important part. There we can create, we already discussed that question, it is there in your notes. But again I repeat, CCl4 does not undergo hydrolysis, but SiCl4 undergoes hydrolysis, assertion. What is our assertion? Carbon and silicon both are brothers, same group. So CCl4 does not undergo hydrolysis. SiCl4 undergoes hydrolysis. This is assertion. Reason, due to the presence of vacant d orbitals in silicon of SiCl4. So the reason for why SiCl4 undergoes hydrolysis it has vacant d orbital. The water molecule in hydrolysis donates a lone pair to this. So forming a coordinate covalent bond. It becomes OH2, O gets plus charge. When O becomes plus, it is very unhappy because O is electronegative atom. It would like to carry negative charge. When it is carrying positive charge, it asks one of the bonded hydrogen to give its electron pair and leave as H plus. When H plus is going, one Cl also says, I will also come with you as Cl minus. We both can go as HCl and live together very happily. So this is the compound we are getting. But again it will react to what? Same story. Again O get plus charge. It is become OH2 plus. Already one OH is substituted here. Now this O plus takes the bond pair from H, and one H plus and one Cl minus are gone. So finally what you are getting? Like this, it repeats. So what is the final product? SiOH 4 times. This is also called, or you can also write as H4SiO4, which is called orthosilicic acid. Silicic acid. On strong heating, it gives SiO2 plus 2H. So SiCl4 can act as Lewis acid, electron pair acceptor. What is a Lewis base? SiCl4 completely undergoes hydrolysis. During hydrolysis, what is liberated? HCl is liberated. Whenever HCl is liberated in a particular reaction, it gives fumes. So SiCl4 fumes in moist state due to hydrolysis. SiCl4 fumes in moist state due to hydrolysis. Germanium tetrahalide is more stable than GeX, third one. That is also true because only in 14th group tin and lead show earth pair effect and dihalides are more stable. So tin and lead, Sn and Pb only show inert pair effect and their dihalides are more stable. But the remaining three elements, carbon, silicon, germanium, their tetrahalides are more stable because they don't show inert pair effect. Only the last two elements will show inert pair effect. Stannic fluoride, SnF4. This is ionic, that is true. Next, match the following. Pure nitrogen is matched with the fourth option, sodium azide or barium azide. We already discussed this. Sodium azide, NaMp. 2Na plus 3N2. Barium azide, These two reactions occur in car airbags. Hope you know recollect. Whenever a car met with an accident, suddenly the airbags open and they act as a cushioning material and prevent the people crushing to death. This cushioning material, airbag, how they suddenly open and act as a balloon and act as a cushioning material because of the decomposition of sodium azide or barium azide. Spontaneously it occurs based on impact of the collision. To suddenly apply brake, the airbag won't open. Only the car should feel, the sensor should feel the collision impact is very high. Then suddenly all the airbags will open. So pure nitrogen is prepared by decomposing. Haber's process, ammonia. B is matched with 3. This is Haber's process. N2 gas plus 3H2 gas. 2NH3 gas. This is Haber's. Contact process. 2SO2 gas plus O2 gas, 2SO3 gas. They come in contact with a catalyst called V2O5 catalyst. These two gases come in contact with a solid catalyst. Thus it's called contact process. It is an example of heterogeneous catalysis. Deacon's process. Aerial oxidation of HCl. HCl plus O2 gives H2O plus Cl. 2H2O, 4HCl, 2Cl2. Chloride catalyst. This is a Deacon's contact process. Haber's. So very simple question. Which are the following diatomic molecular species has only pi bonds according to MOT? This is also discussed. Shall we go back? Over. Okay, carbon 12. C2 molecule with 12 electrons. If you fill sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Next is pi 2p y2, pi 2p x2, sigma 2p z 0, pi star 2py 0, pi star 2px 0, sigma star 2pz 0. So if we cancel this and this, the bond order is equal to number of bonding electrons 4 minus number of anti-bonding electrons 0 by 2. So C2 molecule will have a bond order of 2, means 2 bonds. Both the bonds are formed by pi molecular orbitals. That's why both are pi bonds. Generally double bond contains left to right IE increases. Ionization energy increases. But with some exceptions. Beryllium and boron is one exception pair. Nitrogen and oxygen is another exception. Because nitrogen has half-filled p orbitals, it is having more stable configuration. Similarly, beryllium has full-filled orbitals, it has also stable configuration. So the final order, Li less than, boron less than beryllium, less than carbon less than oxygen, nitrogen less than fluorine less than neon. This is the correct IE1 order, first ionization energy order. Next, the biodegradable polymer. Polymers also not there, please round it up. But the answer is nylon 2, nylon 6. Now 62nd question. pH of saturated solution of calcium hydroxide is 9. The solubility product KSP of CaOH twice. So pH of CaOH twice is equal to 9. You know pH plus pOH is equal to 14. So pOH is equal to 14 minus pH. 14 minus 9 is equal to 5. Then OH minus concentration is equal to 10 power minus 1. So CaOH twice dissociates into Ca2 plus 2 OH minus. So if its solubility is S mole per liter, it becomes S mole per liter. This becomes 2S mole per liter. Now this 2S mole per liter is given as 10 power minus 5 mole per liter. Then S become 10 power minus 5 by 2. Now KSP is equal to calcium ion into the hydroxide ion concentration whole square. Calcium ion concentration is S only, means 10 power minus 5 by 2 into OH minus concentration is 10 power minus 5. whole square. You simplify it. You get the value 0.5 into 10 power minus 15. First option. Next question. The rate constant for first order reaction is K. The time required for the completion of 99% of reaction is given by. So K is equal to 2.303 by T log A by A minus X, or T is equal to 2.303 by K log A by A minus X. 2.303 by K into log 100 minus 100 minus 99. That is equal to 2.303 by K into log 100. Log 100 is 2. Into 2. 4.606 by K. This is T. First order rate constant K is equal to 2.303 by T log A by A minus X. The non-essential amino acid among the following. What are essential, what are non-essential? Non-essential means they make in our own body. They are not required to take from outside. So essential means which we take from outside. They are essential amino acids. So here, it's a memory-based question. Alanine is non-essential. Alanine. Next, among the following, the reaction that proceeds through an electrophilic substitution. Direct question. So Cl-Cl bond it is a Lewis acid. So this bond undergoes heterolysis. One Cl become plus, one Cl become minus. This Cl minus is taken by AlCl3. So that gives an electrophile plus AlCl4 minus. Now this electrophile attacks the benzene ring. Or benzene donates one of its pi bond. So you get Cl, a carbocation called erinium ion. Or it is also called sigma complex. Now this erinium or sigma complex, here benzene has only 2 pi bonds now. It is not that much stable. To get stability, one of the hydrogen gives its bond pair and last as H plus, resulting chlorobenzene. Now finally the H plus react with the AlCl4 minus in the first step, forming AlCl3 plus HCl. These are the mechanism of electrophilic aromatic substitution in the chlorination. Chlorination of benzene of an example of EAS, electrophilic aromatic substitution. Here the electrophile is chloronium ion. What is the name of this electrophile? Chloronium ion. Generally we use it to write Cl minus. Here Cl plus is somewhat undigestible, but don't worry, it will be forming. In the hydrolytic bond fission, always ions are formed. In the homolytic bond fission, free radicals are formed. So heterolysis always give ions. Homolysis give free radicals. So that is the difference. Now the first one, write the option itself, Sandmeyer reaction, which is an example of free radical substitution. First one is FRS, free radical substitution. Third one, benzene to benzene hexachloride. Now write the product side in the third option, BHC, benzene hexachloride, which is also called lindane, Lindane, which is also called 666, 666. 6 carbons, 6 hydrogens, 6 chlorines. In benzene, 6 carbons are there. At each carbon there is 1 hydrogen. Correct? Generally we don't write. Now if you take benzene with chlorine in the presence of sunlight or UV light or HNO, it occurs as a free radical addition. It is free radical addition. At the place of each pi bond, 2 chlorines are added. So resulting compound, one pi bond, second pi bond, two chlorines are added, third pi bond, two chlorines are added. It is addition, not substitution. Hydrogens are already there. How many hydrogens? 6 hydrogens. How many carbons? 6 carbons. That's why it is called triple six. An important insecticide. Benzene hexachloride is an important insecticide. Now at the fourth option, it is benzyl alcohol, HCl heat, forming benzyl chloride. OH minus is replaced by Cl minus. That's why it is called a nucleophilic substitution. It is called nucleophilic substitution. Next question. The mixture that forms maximum boiling azeotrope. The mixture that forms maximum boiling azeotrope. So, solutions divide into ideal, non-ideal. So in ideal solutions, they obey Raoult's law. At all concentrations. Now delta H mixing is equal to 0. Or you can also write delta mixing H. This is now the NCERT is representing. Delta mixing V is also 0. The magnitude of AB molecular interactions are same as AA and BB.
Sir, what about delta mixing of G? Delta mixing G.
No, I'll explain. We are giving delta, what is
It's already
delta mixing?
G.
Actually, you are asking free energy change, no. Entropy and free energy are not zero. You are asking delta G mixing, no. So actually, if you take 100 ml of, that is this 100 ml, I have taken benzene. 100 ml benzene. taken 100 ml. Toluene. Let us say I put a thermometer here and measure temperature T1 degree centigrade. Here also let us say both are at the same temperature. Now I mix both of them. Then the resulting volume I measured. So benzene plus toluene. Exactly it is 200 ml. So during mixing, the volume has not increased or decreased. And the temperature also I measured. Again I got T1 degrees. So no heat is evolved nor absorbed. Then the solution is called ideal solution. So in ideal solution, after mixing, this is called AB molecular interactions. Before mixing, this is AA interaction, this is BB interaction. Between molecule of benzene, we call AA molecular interaction. Between the molecules of toluene, we call BB interaction. So the magnitude of these interactions after mixing also, the AB interactions are of same value or same magnitude like AA, BB. Then the solution becomes ideal. That ideal solutions obey Raoult's law at all concentrations. And the B total, so let us say it is exerting an vapor pressure, some P1. This is exerting a vapor pressure P2. So the vapor pressure P total is equal to P1 plus P2. The vapor pressure, if both are volatile components, benzene is volatile, toluene is also volatile. That's why their molecule change in vapor state. Let us say benzene vapor pressure is P1 mm of Hg and toluene's vapor pressure is P2. So after mixing, the total vapor pressure should be equal to P1 plus P2. Then the solution is ideal. Now in case of non-ideal, which are divided into two types, which show negative deviation from Raoult's law. Positive deviation from Raoult's. For example, the question given, water plus nitric acid, water plus nitric acid. You know, water boiling point 100 degrees. Nitric acid 83 degrees. The boiling points. When you mix this in a particular percentage, for example, water should be 32%. They are not given but percentage is more important. This is 68%. Then the boiling point of the mixture is 126.4. So this is called maximum boiling azeotrope. Please write other examples also. HCl and H2. Example 2. HCl and H2. Example 3. HF and H2. Perchloric acid and water. Chloroform and acetone. This is very, very important. You tick this and write important. Actually, based on this, we can explain everything about negative deviation. So when you mix chloroform and acetone, CHCl3 plus acetone, O double bond C. Because of this electron pulling nature, minus I effect of 3 chlorines, hydrogen acquires maximum positive charge. You know, in acetone, O gets negative charge. So whenever chloroform and acetone are mixed, the partial positive H, partial negative O, they develop intermolecular hydrogen bond. Intermolecular hydrogen bond. Now let us say this is A. The solution contains minimum 2 components. This is B. When chloroform is separate, between chloroform and chloroform, the molecular interactions are AA interactions. When acetone is separately present, the acetone-acetone interactions, they are called BB interactions. Now you mix chloroform and acetone. Now you got AB interactions. Now can you figure out, when compared to AA, chloroform interactions, BB, acetone-acetone interactions, now chloroform and acetone interactions, which are stronger? Very good, AB. Because hydrogen bonds are formed, AB molecular interactions are strong. Thus, after formation of this solution, by mixing chloroform and acetone, since the molecular interactions are strong, their relative tendency to go into vapor state decreases. When they are separately present, they can easily go into vapor state because their molecular interactions are weak. Correct? Now you have mixed, the molecular interactions become stronger due to intermolecular hydrogen bonds. Thus the relative tendency of the molecules to go into vapor state decrease. So whenever the vapor pressure is low, you have to give more temperature to rise their vapor pressure to reach the atmospheric pressure. That is called boiling point.